Welcome to solverfy.
Hello student. So the question is to calculate the resulting pH in a stream. So these are the notes where the cyanide concentration is 0.01 molar at pH 10.3. So in step 1 to calculate the concentration of cyanide in waste holding pond. So the pH is 10.3 and we'll consider the pKa of the HCN, which is 9.31. So we will be using the Henderson-Hasselbalch equation to find the concentration of the cyanide ion. So here the Henderson-Hasselbalch equation is pH is equal to the pKa plus log of the concentration of cyanide ion divided by the concentration of HCN. So let's put the value to calculate the concentration of the Cn negative. So here the pH of the pond is 10.3 and it is equal to the pK of HCN, which is 9.31, plus the log of the concentration of Cn negative ions divided by 0.01, which is the total concentration of 0.01 minus the concentration of Cn negative ions. Now by solving this whole equation, we'll get the concentration of the Cn negative ions, which is equal to 0.00957 molar. Now, so the step 2 is to find the concentration of the Cn negative ions in the stream after mixing. Since we have been given the pond water mixes to the stream at the ratio of 1:10. So, we'll consider the concentration of the Cn negative ions in the stream will be equal to the concentration, which is 0.00957 molar divided by the total of the ratio, which is 11. So here we'll get the concentration of the Cn negative ions in the stream and it is equal to 0.00087 molar. So now in step 3 we'll be calculating the concentration of HCO3 negative ions in the stream at pH 8.3. So here the pKa1 of the H2CO3 is 6.35 and the pKa2 of the HCO3 negative is 10.33. So let's use the same Henderson-Hasselbalch equation. So from that equation, we'll put the value of pH, which is 8.3, which is equal to the pKa 6.35 pK1 plus the log of the concentration of the HCO3 negative ions divide by the 1.4 into 10 raised to the power minus 3 minus the HCO3 negative ions. So by calculating this is 1.4. So by calculating this, we'll get the concentration of HCO3 negative ions. Solving for the HCO3 negative ions, the concentration is 0.00133 molar. Now we'll calculate the pH of the stream after the mixing. So we can use the charge balance equation, where the concentration of the H plus ion is equal to the OH negative ions plus the concentration of HCO3 negative ions plus the Cn negative ions. So from here, since we know the ionic strength of the stream, which is equal to 0.02, we can find the concentration of H plus and the OH negative ions using the ion product of the water. So here the ion product, which is Kw of the water, ionic product constant is 10 raised to the power minus 14, and now we'll be using the Debye-Huckel equation to calculate the concentration of H plus ion. So here the Debye-Huckel equation is concentration of H plus ion is equal to the under root of Kw divided by the gamma of H plus ions and the gamma of OH negative ions. So by rearranging it, we'll get the OH negative ions, and now by calculating this and putting the value in charge balance equation, we'll get the H plus concentration and we'll get the final pH. By substituting it, we'll get the final new pH, which is 8.22. So this is the answer. I hope you find this video helpful. Thank you.